Hello dear students, how are you? Today we are going to discuss about electrocyclic reactions. We will discuss some important points about electrocyclic reactions. So don't skip the video and watch the video till end. Right? As I told you already, when there are even number of conjugated pi bonds, when there are even number of pi bonds, then the reaction is thermal conrotatory and photochemical disrotatory. Right? If there are odd number of pi bonds, if there are odd number of conjugated pi bonds, then what happens? Then reaction is photochemical conrotatory and thermal disrotatory. Right? I once again repeat, when there are even number of conjugated pi bonds in electrocyclic reaction, then reaction is thermal conrotatory and photochemical disrotatory. Whereas when there are odd number of pi bonds, then reaction is photochemical conrotatory and thermal disrotatory. Now question arises, why there is thermal conrotatory? Right? Why thermal conrotatory and thermal disrotatory is not there? Right? And why photochemical disrotatory is there? And why photochemical conrotatory is not there? Right? I once again repeat, question arises, why thermal conrotatory is there and why thermal disrotatory is not there? Then second point is, why photochemical disrotatory is there and why photochemical conrotatory is not there? These are questions. If we talk about when there are even number of pi bonds, right? If there are even number of pi bonds, then why thermal conrotatory is there, thermal disrotatory is not there? Then photochemical disrotatory is there and photochemical conrotatory is not there. We will discuss these points one by one. We take example of butadiene. This is butadiene. In this case, there are two conjugated pi bonds. There are two pi bonds, right? Means there are even number of pi bonds. So in this case, there are two pi bonds, means even number of pi bonds. So reaction is thermal conrotatory and photochemical disrotatory. Now, why thermal uh, thermal disrotatory is not there and why photochemical conrotatory is not there? I have drawn homemade LUMO for butadiene. So this one is HOMO for thermal reactions, right? And this one is photochemical HOMO for butadiene, right? If you don't know how to draw HOMO and LUMO for butadiene or hexatriene, etc., you can watch my video on HOMO and LUMO. To discuss all these, we take HOMO of butadiene, right? Now, why thermal convertatory reaction is there and thermal dissociatory reaction is not there? This is thermal HOMO, right? This is thermal HOMO of butadiene, right? In this case, if we rotate these bonds convertatory, this lobe move to this side and this lobe move to this side, right? We get this type of combination, and in this case these two same lobes interact, so there is bonding, right? If you don't know what is convertatory motion or what is dissociatory motion, you can watch my videos. I have video on these topics. If you take thermal HOMO of butadiene, what happens if these two bonds rotate convertatory? What happens? The two same lobes interact, so there is bonding. So why there is thermal convertatory, right? This is answer why there is thermal convertatory reaction, because these two same lobes interact and we have bonding interaction in this case. Now second point is why thermal dissociatory is not there. Let us see. In this case, if these two bonds rotate, right, what happens? This is dissociatory motion. If these two bonds rotate like this, we have this type of bonding interaction. In this case, the two same lobes are not facing each other, so there is no bonding, right? So this is answer why thermal convertatory reaction is there and thermal dissociatory reaction is not there if pi bonds are even, right? In this case, if there is convertatory motion, we have bonding interaction, two same lobes interact and there is bonding. In dissociatory motion, two same lobes do not interact, so there is no bonding. There is no possibility of bonding, so thermal dissociatory reaction is not there. Now third question is why photochemical dissociatory reaction is there if pi bonds are even. Let us see here. If there is disrotation, right, if there is disrotation, we get this type of bonding interaction, and this is allowed bonding interaction. This type of interaction is needed for bonding, so this is bonding interaction, right? If there are even number of pi bonds, then photochemical dissociative reaction is there. This is photochemical HOMO. This is photochemical HOMO of butadiene, right? And this is photochemical HOMO of butadiene. When pi bonds are even, then photochemical dissociative reaction is there, as we see in this case. If these two bonds rotate dissociatively, then we have this type of bonding interaction. So why photochemical dissociative reaction is there? This is answer. Because if we rotate these bonds, we get bonding interaction. And our last question is that if there are even number of pi bonds, then why photochemical conrotation is not there? We have answer here. If these two bonds rotate conrotatively, we have this type of bonding interaction. The two same lobes do not interact, so there is no bonding interaction, and no bond is formed in this case, because for bonding the two same lobes are required. In this case, if these two bonds rotate conrotatively, then there is no reaction, there is no bonding, so photochemical conrotative reaction is not there. Right, guys? So this was all about electrocyclic reactions, some important points of electrocyclic reactions.